Good morning, this is your Stat Sensei, Mr. Spensei, and this is a continuation of the test review. We will do scenario 2. Scenario 1 was on the prior video. So a financial analyst claims that the mean monthly expenses for a group of 2,400 investors is $3,000. So the claim is this, so that sounds like that's the population mean. We'll probably need to come back and check that. The mean is $3,000 with the standard deviation of 657. Standard deviation is $657. A simple random sample of 40. Second, N is 40. Shows a mean monthly expense. So from the sample, so this mean is our X bar of 2,850. Test the hypothesis that the mean monthly expense is less than 3,000 at the 6% level. So alpha equals 0.06. All right, so we have two parts. We have a hypothesis test and a confidence interval. We'll do the hypothesis test first, and then we'll come back and run the confidence interval. Take a moment while I fold the sheet of paper. All right, so our hypothesis. Well, they told us they were claiming that it was 3,000. So we're going to go the null HO mu equals $3,000. The alternative is mu is less than that. So the alternative is mu is less than $3,000. The parameter, let mu equal the true population mean monthly expense. All right, true population mean monthly expense for investors. Conditions. Well, our first condition is always random sample. And our random sample is of size 40. And that was given. So nice of them to give us something. 2, N is less than 10%. 40, N equals 40. 40 times 10 equals 400. And that's less than 2,400. So we can check that off. Number 3, we needed to check to normality. Well, they didn't tell us it was normal. Some expenses could be really large, but N is 40, which is greater than or equal to 30. Normal by CLT, by central limit theorem. Please understand that on number 2, we'll always multiply by 10 and then compare it to the population size. Here, we'll take our sample size and we'll always compare it to 30. Our formula is Z equals X bar minus mu standard deviation divided by the square root of N. We need to draw a picture of this. Well, remember, we're always centered on the claim. And our claim is that it was 3,000. But our X bar was 2,850. And they wanted to know if it was less than, so that's the way we're shading. So we might as well circle this. Please ignore the D. Mean is 3,000. X bar is 2,850. Our sample mean, our population standard deviation is 677, and our sample size was 40. So we're going to need to plug into our formula. So we want the probability that Z is less than 2850 minus 3000 over 677 divided by the square root of 40. So we want the probability that Z is less than. So stat test Z, Z test, mean 3000, standard deviation of 677, X bar of 2850, sample size 60, calculate. We ended up getting 0.04. So probability that Z is less than negative 1.7162 is a probability, gives us a p-value of 0.0430. Our p-value is 0.0430. Our alpha, they said that they wanted to use 0.06. So this is less than. Make sure you make them the same length. 430 is less than 600. So our decision is to reject the null. We reject the null. So our conclusion, remember we start off with restating our p-value. Our p-value is 0.0430. What was our decision? We reject the null. In this case, there is sufficient, there's enough, there's plenty. There is sufficient evidence at alpha equal 0.06 there's sufficient evidence at alpha at alpha equal 0.06 to say that what? The true population mean monthly expense for investors, that the true population mean monthly investors is our alternative was less than 3,000. So that's what we say here, is less than $3,000. All right, so that takes care of that. We still need to do a confidence interval for the same problem. So let's take a look at what they're asking for. So calculate a 94% confidence interval, so just a 94% interval for the mean monthly expenses of investors, and comment on whether there's enough evidence to support the claim that they're less than 3,000. That's interesting. So a confidence interval. So first off, the parameter, it's going to be the same as before, but because we refer to it, I am going to copy it down because we will be referring to the parameter. So let mu equal the true population monthly expense for investors. All right, the conditions, I'm not going to do them again. We already showed that they were met and they are the same, but I will run through them. So we have a random sample of 40 and that was given. The N is less than 10%. 40 times 10 is 400. That's less than 2,400. So we're good there. And normality by central limit theorem because 40 was greater than or equal to 30. Our equation for the confidence interval is going to be X bar plus or minus Z star standard deviation divided by the square root of N. Our information is our standard deviation was 677. That was the standard deviation from the population. That hasn't changed. Our sample size was 40. Our X bar that came from the sample mean was 2,850. And our confidence level was, our confidence level, they said run a confidence test of 94%. So we need to make that confidence level 0.94. Next thing we need to do is calculate our Z star. So this area right here, 0.94. We're working with a Z-test, so we're centered on 0. This is my lower, this is my upper. So this will be an inverse norm. 0.94, 0, 1, center. Second var, second vars, inverse norm, 0.94, mean is 0, standard deviation of 1, once again, just because it's a z-score. And we have negative 1.88 and positive 1.88. So negative 1.8807 to positive 1.8807. And we're really interested in the positive. So we're going to plug in, and we have X bar of 2850, 2850, plus or minus our Z star, 1.8807, our standard deviation, 677, over the square root of 40. When we calculate our interval, stat test number 7, and our standard deviation 677, our sample mean of 2850, our sample size was 40, and we need a confidence of 0.94. And we end up getting 2648 to 3051. 2648.7 to 3051.3. So our conclusion, we are 94% confident that the true population mean monthly expense for investors. Now that came from our parameter, that mu equal to true population mean monthly expense for investors. I left off mean earlier, so I had to come back and add that. Lies within the interval $2,648.70 to $3,051.30. The next thing, the meaning. That's just where it says, hey, what happens if we did this over and over again? How good is it? So in repeated sampling, we expect this method to capture the true population mean monthly expense for investors 94% of the time. All right, very last thing, based on the interval, is there enough evidence to say that the expenses are less than $3,000? Justify your answer. No. We cannot say it is less than $3,000 because 3,000 lies within the interval, which makes it a plausible value. All right, it's 3,000 is plausible value because it lies within the interval. So no, we cannot say that the interval shows that it's less than 3,000. All right, for the interval to show that it's less than 3,000, we'd have to think of a number line. There's 3,000, and maybe our interval went from 2,500 to 2,987. Something that didn't include 3,000, but our interval included 3,000. So nope, can't say it. All right, thanks for watching. Hope to see you on the next one.